Hello, welcome everyone. In this video, I'm going to cover a couple of properties of logs. One of them is called the power property of log. So if we look at here, we have a definition of a power property of log. We have a log of some number x with an exponent of m with the base c. So we can simplify that particular expression into, we bring the exponent to be the multiplier or the coefficient of the log times log of x with base c. So the difference between this side and this side is that the m here is in exponent form and here it's a multiplier. So basically we can take the m to the front of the log expression and make it a multiplier. It's like this, m times log of x with base c. So let's see if we have this expression, log of x cubed with base 5, and we want to simplify this using the power property of log. What we do, we take the exponent of this x term and bring it to the front and multiply it with the expression. So this 3 goes to the front and then multiplies it with this log of x with base 5. Once 3 is moved to the front, there's no more exponent on x, so x is just by itself, and then we have base 5. So this is the usage of this power property of log. Okay, I'm going to do a couple more examples here so we can just master this. Log of 3 plus x to the third power with base 2. I'm going to go ahead and simplify this one, taking this 3 to the front, so 3 times log of 3 plus x with base 2. So all we did, we took the exponent and we brought it to the front and made it to multiply with the log expression. And since the 3 is moved to the front, there's no more 3 as exponent. And this is the base 2 as it is right there. So this is the simplified form. Let me write a couple more examples here. We have log of 100 cube with base 10, just an example. So I'm going to use the power property of log. This 3 will go to the front, 3 times log of 100 with base 10. And you can of course solve it further, but I'm just leaving it here. So yeah, just to demonstrate the proper property of log. If you want to solve it further, you can go ahead and solve this expression right here. This would be this right here. Basically, it's asking you to do 3 times, it's asking you to, what is 10 to the power x equals 100, which is 2, because 100 is basically 10 squared, so 10 to the x equals 2. So the bases are same, so x is equal to 2. So you can solve this right here. It becomes 3 times 2, which is equal to 6, if you want to solve it further. But that wasn't the purpose of this video. It was just to show you how to use the power property. This is up to you if you want to do it, but if the question asks you to do it, then you have to do it. Let me do another example. We have log of, we have x plus z to the second power with base 10, and we want to use the power property of log. So this 2 becomes the exponent becomes a multiplier with log of x plus z with base 10 right here. Here we go. All right, so hopefully this helps on how to simplify the power property of log. Now let's go to the next section. Here we are going to work on a equality property of log. This one shows or says that if log of a number x with the same base equals log of a number y with same base, then x and y are equal. So we're going to go ahead and do some examples. Usually it's done to solve some equations, unknowns. So like I'm going to put an equation and we're going to go ahead and solve it using this property. So if we have a log of 3x minus 2 with base 5 equals log of 5x minus 10 with base 5. All right. So we have an equation like this right here. We want to go ahead and solve this equation. So how do we solve it? Well, that's where we use this equality property. So basically, if we have taken the log of 3x minus 2 with base 5, and that is equal to log of 5x minus 10 with base 5, if bases are the same, then the logs, then these must be same. So it must be equal. I'm sorry, not same. So 3x minus 2 must be equal to 5x minus 10 by using this property of the log. So now we can go ahead and now it's a very simple equation. It's just a linear equation. We can solve it. So we add 10 on both sides. So this cancels out. You have 5x equals 8. And you have 3x plus 8. So this becomes a positive 8 when we add a positive 10 and a negative 2. So the sum is equal to positive 8. And now we get rid of this 3x from this side by subtracting it. So if we do it on one side, we do it on the other. So this is gone. Now here we are left with 2x when we subtract 3 from 5. And then on this side, we are left with still 8. And now we divide by 2. So x is equal to 4. All right. So this is how we go ahead and solve this, the equation. But it looks pretty complicated here. But if we know which property of log to use, then it becomes really simple, like linear equation. And we can go ahead and solve for the unknown from here. In the next example, I'm going to do something a little different. We have log of x squared minus 3x with base 5 equals log of 10 with base 5. Okay, now we have a quadratic equation here. If you see this x squared term, so we can still apply our equality property of log. If the bases are the same, then the two expressions on both sides must be equal. So this is x squared minus 3x equals 10 because the bases are the same. So we can apply the equality property of the log. Now we basically bring everything on one side. We subtract 10. So we have x squared minus 3x minus 10 equals 0. Now we go ahead and factor this out. We have x squared minus 5x minus plus 3x plus 2x minus 10 equals 0. I just use my factoring method. You can use any factoring method that you know about. So I factor out x from here. So you have x minus 5 and you have factor out 2 from here. You have x minus 5, and that is equal to 0. So we have x plus 2 and x minus 5. So these are the two factors of the equation. So x plus 2 equals 0, x minus 5 equals 0. So x equals -2 and x equals plus 5 if you solve these equations. So this is what we get for the answer of this equation right here. So this particular property, we normally use it with these kind of questions where you're given quadratic equations or different kind of equations and we solve for the unknowns. And then we manipulate using the property, and then it becomes a lot easier to solve after that. So hopefully that helps. Thank you.